Good.
Right, morning guys. If you could comment your names. Sorry about the delay today. I couldn't get connected to the internet. I think it's all working now. So, as we said yesterday, we're going to do some partial fractions and then look at some parametrics. So I thought get partial fractions out the way nice and quickly. I've got two of them here. And then we'll start having a look at parametrics. So I'll start doing the register now. If you guys want to take 8 minutes to get started on these two. And let's get on with some stuff. So 8 minutes starting now. Comment all your names and I'll open up the Teams chat as well. Right, I haven't had any responses yet. So, do you guys want a bit more time, or should I start going through it? Actually, Fifi's just sent me hers. So Fifi, you've done the first one. Do you guys all need more time to do the second one as well? Let me know, so I can give you another couple of minutes if you need. Well, we'll go through the first one, and then if anyone's done the second one by then, we can go through that too. So, first one. Yeah, so we're going to split it up into, as they've said there, A, B, C over those fractions. So if you say 10x squared, take 10x plus 17 equals A, x minus 3 squared plus B, 2x plus 1 x minus 3 plus C, 2x plus 1. So that's like the setup for this. So we're going to put in values 3 and minus a half. So let x equals 3 first of all. So we get 90 minus 30 plus 17. A is going to disappear, B is going to disappear, and we're going to get C times 7. So 77 equals 7C, so C equals 11. Then let's put in x's minus a half. So we get 10 over 4 plus 10 over 2 plus 17 equals minus a half take 3 squared, which is 49 over 4. So if you work out what's on the left there, 10 over 4 plus 5 plus 17. 49 over 2 is 49 over 4a. So we get a equals 2. Cool, right, once you've got a and c, we can now put in any value to try and find b. So I'm going to put in a and c, and I'm going to say let x equal something easy like 0. So we get 17 equals 18 plus b times minus 3 plus 11 times 1. Cool, so 17 take 18 take 11 divided by minus 3 gives us b, which is 4. So you can then write those up in there, but really it just wants you to find those, so that's absolutely fine. Alright, let's have a look at what you guys have done. Cool. Yep, good. So that was Fifi, well done. Alex, well done. Callum, well done. And Becca, well done. Cool. Alright, I'll give you guys a couple more minutes to do the number 7 there. So what, 3 more minutes? Cool. All right. Yes, a couple of you have done it, I think. All right. Let's give this a go then. So they've done the first bit for us. So 39x squared plus 2x plus 59 is a times x, a times 3x. Take 1 squared plus b times x plus 5. 3x take 1 plus c times x plus 5. Let's make x equal minus 5. So we get 39 times 25 minus 10 plus 59 equals, everything cancels apart from the a term, so we get minus 16 all squared. Then we get a is 4. So same again, make x equal 1/3. So we get 13 over 3 plus 2/3 plus 59 equals, this time everything apart from c is going to cancel out, so we get c 1/3 plus 5. I'm working out what c is. C equals 12. Okay, now with the two of those, put in x equals 0, then we should be able to find what's going on. So we get 59 equals 4 minus 5b plus 12 times 5 is 60. So if we rearrange this, 59 take 64 divided by 5 gives us b is minus 1. Cool, there we go. And then you want to write it out with a, b, and c at the top. So 4 there, minus 1, and 12. Cool, and that's all I wanted to do on these. Key thing to remember is when you got a repeated root, you write the root once and then the root repeated. So you can see up there. 3x take 1 squared splits into 3x take 1 and 3x take 1 squared. Cool. Alright, for the rest of today I want to look at parametrics. So we're going to try and just cover a load of these. We'll start off with an easy one, then we'll start looking at some trig, and then we might get to some differentiation integration at the end. So if you guys could try this, it's actually 2 questions, isn't it? Let's give you guys 10 minutes to do both of those, and I will check for your answers to the last one in a sec. So 10 minutes on the clock. Give these a go. Comment if you need any help though. But these, I think the first 2 should be pretty straightforward. Cool. If you guys have had a chance to do the first one, maybe not the second one. Let's go through the first one, and I'll give you a little bit longer for the second one. So, if I need some paper, give me 2 secs. Cool. We'll find out where in a sec if you so follow along, see if you can spot it. Right, so you've got curve of parametrics, determine the range of x, so the ranges of x and y in the given domain of t. Okay, so we need to find out what x and y values are available. So the easiest way to do these is to sketch them. So for the x one, let's draw x there against t. We've got 1 over x graph. No. Green screen. Got 1 over x graph plus 2. So 1 over x plus 2 is going to move it upwards. So that's like it's like that. But t is not allowed to equal 0. So to be honest, we get all x values apart from 2 there by the looks of it. So we can say x is not equal to 2. Same thing for y. So y is a quadratic here. I'm just going to type this into the calculator so you can get an idea of what it looks like. So the quadratic has a minimum or a maximum at 1 minus 2, so it's actually there. And we know that t can't be 0. So y is, what's that going to be? That would be minus 2. Cool. So y must be less than or equal to minus 2, and y cannot equal wherever that value there is. That value there will be minus 3. Think is the best for that one? Let's have a look at what you guys said. Or do you got y is less than 1? Where do you get that from? Pretty sure my quadratic's right there. Minus 1, 2, minus 3, yeah. Anybody got that bit right? None of you sketched it, which is not good. Yeah, so I'd always sketch when you're trying to find range and domain. But yeah, those should be your ranges. So if you're not sure about that, sketch it, and you can then see. Okay, show the Cartesian is that. So easiest way to do this is to rearrange x and then put that into the other equation. So we're going to say x equals, or x take 2 equals 3 over t. So t equals 3 over x take 2. And we're going to put that in to the equation there. So y equals 2 lots of this, so that's going to be 6 over x take 2 minus 3 minus 9 over x take 2 all squared. Yeah, it looks messy, but I don't think there's much else we can do with that. We could, I suppose we could find a common denominator. Oh wait, yeah, they wanted to show it's in that form. Okay, yeah, so we need to find a common denominator. So I got to this stage, I'm going to times everything through by 1 over x plus 2 that needs it. So you get 6x minus 2 over x minus 2 squared minus 3x take 2 all squared over x take 2 squared minus 9 over x take 2 squared. Expand the top, so we get y equals 6x take 12 minus 3x squared plus 4x minus 4 minus 9 all over x take 2 all squared. Which gives me y equals minus 3x squared plus 10x and then 12 and then minus 25. I think that's it. Am I doing something wrong here? Yeah, I think I've made a mistake. Can anyone spot what I've done? I'm going to put that back up. See if you guys can see what I've done wrong. I will rewind and find it in a sec. Alright, I think my expansion of the quadratic was a bit iffy. Yeah, I didn't times those terms by 3, did I? Cool. So I believe that should be a 12, and that should be a 12 there as well. So this will be minus 3x squared plus 18x minus, what's that, 12, 12 and 9. Minus 33. Let's take out a factor of 3, or even minus 3, x squared minus 6x plus 11 over x minus 2 all squared. Cool, there we go. Right, I'm going to give you guys a couple of minutes to do the other one because I didn't think that you actually finished it there. So clear drawings. Actually, I don't even need that anymore. There we go. So can you guys try this one? I'll give you 3 more minutes to see if you can finish this off. And then we'll get on to something a bit harder. Cool. Right, let's race through this and get on to the next one. So combining these two, find a Cartesian. So I'm going to rearrange the first one to get e to the x equals t plus 3. So e to the x minus 3 equals 2. So then y equals 1 over e to the x minus 3 plus 5, which is y equals e to the x minus plus 2 over. Write down the range of it. Okay. For the range, we just need to look at the y bit, to be honest. So we've got this equation here. Y is 1 over t plus 5. 1 over t plus 5 is 1 over x graph moved to the left. So that's 5. And t must be greater than minus 2. So our range is going to be this value down to 0. So y is greater than 0 or less than, put minus 2 in, so we get y equals 1 over minus 2 plus 5, which is 1 over 3. So y is less than a third but greater than 0. Okay, Roddy, so you sketched the, what did you sketch actually? Is that the new equation? Did you do that on the calculator? Yeah, it's easier if you just, for the range, just look at the y equation. We don't need the whole equation there. What did I miss? Show the Cartesian is. Oh, okay, yeah. Maybe I did. I need the domain as well. Cool. So if I draw the x one, learn t plus 3, okay. That's going to be minus 2. We know t is greater than minus 2. So x is greater than 0, I think. Yeah. Well spotted. Yeah, so yeah, okay. You were right, Roddy. You were sketching that first bit. Cool. Right, let's move on. I'm going to skip this one because I'd like to do some of trig. So, find a Cartesian for this one. So a little bit of algebra. 6 marks, 6 minutes. This should be easy if you can remember your trig equations. So time starts now. Alright, so a little bit more difficult now. I'm trying to mix together cot and sine, and they're both double angles. But they're also both squared. So I think the way we need to do this one is to realise that 1 plus cot squared equals cosec squared x. We can change the x's there to 2x's or 2t's, whatever we like. So if we say cot squared 2x is x over 3, and sine squared 2x is, well, 2t in each of these cases, is y over 3. And we know cosec is 1 over sine. I could say cosec squared 2t is 3 over y. And we can just put these into these bits and then rearrange to get y. So we get 1 plus x over 3 equals 3 over y. So, with that, I'm going to rearrange to get y on its own. So I need to basically flip both sides. So I'm going to get y over 3 equals 1 over 1 plus x over 3. And then I can times both sides by 3 to get y equals 3 over 1 plus x over 3. And we can leave it like that, or I can times the top and the bottom of the fraction by 3 to get y equals 9 over 3 plus x. Might be a nicer way of writing things. Right, the other bit then, so we also need to find the domain. So I'm going to be looking at my cot graph. So if you can remember what cot looks like, which I normally forget, I think cot is this one, isn't it? But of course we're stretching it by 3 and something it by 2. So we need to know what point this point here is. Oops. We know that point there is obviously the 0, so we can get rid of this bit here. We just need to work out where pi by 4 is. So where does cot normally cross? Well, cot normally crosses, or the asymptote is normally, if you think about it, where tan would be equal to 0. So the tan is 0 at 180, so that would be pi. You can see from the rest of it there. So this is going to be pi. Obviously we have, well, first of all we've squared it. So if we're squaring it, it's going to kind of look like a bit more like that. And what's we got? So pi. We've also squashed it, so we're going to get twice as much in that boundary. So I can actually then get rid of this. That would be pi. So pi by 2 would be here. So pi by 4 would be like that. So we can then say x has got to be greater than or equal to 0. Everyone all right with that? So I always try and think of it in terms of these sketches. Let's see what you guys have done. George, I don't get where you got the maximum from. Can you explain that to me? Why have you got a maximum value for x? Because I think there should just be an asymptote there. Oh, your equation looks good though. Roddy. Good. Has anyone got any questions about the domain on this one? Just wait and see what you're going to say quickly. Everyone okay with this, or has anyone got any bits that are unsure with the domain? I can show you on the graphical. I probably should have done this graphical calculator anyway. Let's bring it up and have a quick look. There we go. So we are sketching. Let's delete all this. So 3 times is going to be 1 over tan squared. Tan 2x. This doesn't really matter I put the square, I'll put it over the whole thing, squared. Cool, so we're going to draw that. We're going to ignore what it looks like. We're going to go to the window. We're going to make the x min and max 0 and maximum pi by 4. Cool. Y, yeah, we can go from 10 to minus 10, that's fine. And I think we're just going to check that we are in radians. I think we are already in radians. Cool, that's fine. Right, so I've only gone up to 10, so you can see why it's kind of stopped there. If I change my window to 0 to 10,000 or 100,000, you can see we've got that shape, which is what I've drawn here. So yeah, between 0, greater than 0 basically should be my domain. Right, let's try another one. How long have we got left? 20 minutes, okay. Another trig one. See how you guys got on this. 7 minutes, so 7 marks starting now. Right, let's have a look at this one. Don't think any of you've answered yet, but we are running out of time, so let's get started. So find the Cartesian. So we need to. Ooh, this is interesting. We need to mix sine and sine-free t. Interesting one, isn't it? So if I say I could make that sine of 2t plus t. I think this is the way to go about this. So we can say that sine 2t cos t plus cos 2t sine t. And now we can use a double angle formula, right? Y equals 2 sine t cos squared t plus, let's use the sine only version of the cos one, so we get 1 minus 2 sine squared t times sine t. Let's expand all this. Y is 2 sine t cos squared t plus sine t minus 2 sine cubed t. And then we can say 3x equals sine t. So I'm going to put in all the sine t's and x's. So y equals 6x cos squared t plus 3x minus 2 lots of 3x cubed. Right, last bit is to sort out that cos. So we need cos in terms of sine. Well, cos is 1 minus sine squared. So y equals 6x 1 minus sine squared t plus 3x minus, let's cube this, so 3 cubed 27, big number, to get minus 54 x cubed. And 1 minus sine squared t is going to 1 minus 3x squared, so 6x 1 minus 3x all squared plus 3x minus 54 x cubed. Expand that bit so that we get 6x minus, what's that going to be, 9 times 6, 54 x cubed plus 3x minus 54 x cubed, so we get y equals 9x minus 108 x cubed. So what we need to do now is factorize it to get it to look like the form they want us to have. So y equals, does that divide by 9? Yeah. So we get 9x 1 minus 12 x squared. There we go. Right, state the domain and range of this in a given thing of t. Okay. So t is between 0 and pi by 2. If we sketch sine, it's nice and easy for the first one. So it goes up to third and down to minus a third. And we're talking 0 to pi by 2. So we're just really looking at this range here. So we know x is more than 0 and less than 1/3. For y, similar idea. Y is sine of 3t. So we still got our sine graph. And we squashed it by a factor of 3, so we're actually going to get 3 bits all between 0 and 2 pi. So pi will be in the middle of these, so that's going to be, right? No, that's not right. Let's draw this one more time. I think I can do a better job. So 3 lots of, well, if we just go from 0 to pi by 2 and then put 3 lots in there. So sine normally would go to there at pi by 2. We're going to get that times 3, so we're going to get down again, and then down again, and that's going to be pi by 2. So the range we get there is going to be -1 to 1. It looks like we can't equal -1, so y has got to be greater than -1, less than or equal to 1. Cool. Yeah, is everyone right with that? So I would always recommend sketching it for range and domain questions. Right, 10 minutes left. Let's see if we can get one more done. I don't think this is going to happen. Let's go for the second one there. Right, if you guys can try that, 6 minutes, and we'll try and race our way through it as well. So 6 minutes starting now. Give it a go. Right. Okay, part A then. So we need to use the tan and cosec identity. So tan squared plus 1 equals cosec squared. So if I get tan squared on its own, that's going to be x take 5 plus 1 equals cosec. Now here we've got a little bit of a problem. Y over 5 would equal sine. So cosec would be 5 over y, so cosec squared would be 25 over y squared. So we've got x take 4 is 25 over y squared, so y squared is 25 over x take 4, square root everything, y is 5 over x take over x take 4. So that's my Cartesian. Oh, it doesn't want me to square root it. Cool. So we get that as the Cartesian. Finding the range of possible x and y values. Well, I've got the calculator. Here's one I did earlier. So in blue, we've got the x bit. So it looks like x is anything greater than 5. Greater than or equal to. No, greater than 5, because we never quite equal it. And y is going to be greater than 0, but less than this value by my ear, whatever that is. So if I go gsolve, did I want to do that? No, I didn't. Do that again. So gsolve, we want to try and find a y value. So we're going to do y calculation for the red one when x is pi by 2. Have I done something wrong? I'll check that in a second. Oh yeah, the tan one is sec. Yeah, I have done something wrong then. So yeah, it should be, what's that, 1.57? I think that's pi over 2. Oh, y is 5. Cool, you can see that there. So y is less than 5. So that's that bit. Alright, let's go back to the first bit again, because it sounds like I did make a mistake there. Tan squared plus 1 is sec squared. Yeah, I did make a mistake. Okay, that's more annoying. That is definitely more annoying. We got a minute. We can do this. Okay. So x take 5 is still tan squared, so that's still x take 5 plus 1 equals sec squared t. So I need to turn sine into sec squared. Right, so I'm going to turn sine into cos and flip it to get sec squared. Let's get rid of this calculator. So, y over 5 equals sine t. Sine squared then will be y squared over 25 is sine squared t. Sine squared is 1 minus cos squared, so 1 minus cos squared is y squared over 25. So 1 minus y squared over 25 is cos squared. So sec squared is 1 over 1 minus y squared over 25. So I can just put that in there. So x take 4 equals 1 over 1 minus y squared over 25. So I'm going to times up by the denominator and bring x take 4 down. So 1 minus y squared on 25 is 1 over x take 4. Add the y squared over 25 over to get 1 minus 1 over x take 4 equals y squared over 25. Times everything through by 25. So we get y squared equals 25 take 25 over x take 4. I think that'll do. That is in the right form. So yeah, there you go. Cool, right, that was very fast. That's it for us, isn't it? That's it for the year. Cool. There is a quick notice I need to tell you guys. Let me just find this then. So, Cool. Okay. If you guys wait there just for a second, as I think there is some work that you need to do over the summer. Somewhere here. Maybe not. Do we have you next year? Do you have me next year? I don't actually know. I know I have a further maths second year class. I don't know who's in it. You guys can probably check your timetables. I think your timetables are up now. Yeah, let's have a look. I will at some point be sending you guys out some work. So if you could keep an eye on the keep an eye on your email and keep an eye on your Teams chat. I will be sending you some work to do over the summer at some point. But I can't actually find where it is now. So but yeah, I would definitely do some revision over the summer. I know this term has been a bit weird. I don't know what's going to happen next year. I think things are looking like they're going to be normal by the time we start again. But make sure you get some work done over the summer holidays. There are past papers all up on Moodle, so I'd work for a few of those just to keep all the ideas fresh. There will be a test on the first lecture back on everything we've covered this term. So all of the, I guess with Helen you'll be doing one on your matrices, and with me you'll be doing a test on your complex numbers. And there will be some kind of summer work to do as well, but as I said, I can't find where it is right now. So keep an eye on your email, but I will be expecting that on the first lecture back. Where can you find your timetables? On Unity. If you skip forward a few months to October, it should be up. I'm not sure if all of your there's still like a work in progress, but I think most of the stuff is in your timetables now. So yeah, you can have a look, see who you've got, and etc. 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 It'll be a lot based on what you chose though, because I think I'm teaching mechanics, and further pure too. So if you chose stats, you probably got someone else. Yeah. So I don't know. We'll see what's happening. But cool. If I don't have you next year, then it's been a pleasure teaching you all, and I wish you the best of luck. And you can always ask me for help and stuff. Yeah, have a nice summer, guys. It's gonna be a nice long summer. I know maybe some of you have already started summer, but yeah, have a good time. Email me if you get stuck on anything or need any help. Don't know what else to say, but yeah, cheers and bye.